Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter Matrices, which is the third chapter from your 12th standard CBSE Mathematics. We'll continue with Miscellaneous Exercise in page number 100. First question is given as A matrix is given 0, 1, 0, 0 and I is the identity matrix of order 2, which means I is 1, 0, 0, 1. This is the identity matrix of order 2 and we have to show that AI plus BA whole power n, where your small a and small b are numbers and your I and A are capital A and I are matrices. We have to show that this is equal to a power n I plus n a power n minus 1 b into A. So this is what we have to prove. Then this is true for every n belonging to n. And whenever we want to prove anything is true, if this is true for every n belonging to n, we will use the method which is called principle of mathematical induction. Whenever we need to prove anything for every n belonging to n, any statement, this is called as a statement or equation you can say, right? Then whenever we want to prove any statement, this whole thing is called as a statement. For every n belonging to n is set of all natural numbers, then we will use the technique called the principle of mathematical induction to prove this, and that technique has 3 steps, right? So before that, let me write the statement. So proof for this is, we will call this given as P of n. We will call this entire thing as statement P of n. P of n is a statement which is AI plus B capital A power n equal to A power n I plus n A power n minus 1 small b A. This is your P of n. Now there are 3 steps that we have to follow to prove this using principle of mathematical induction. For whenever we need to use principle of mathematical induction, we need to follow 3 steps. Step 1 is we have to prove that this statement is true when n is equal to 1. When n is equal to 1, we have to prove that these two are equal. And then second step is we have to assume that when n is equal to k, this is true, this entire thing is true. That is your second step. We have to assume that when n is equal to k, this is true, that we have to assume. And third step is we have to prove that when n is equal to k plus 1, this entire statement is true, that we have to prove. Fine, so I will do the steps, then you will be able to understand much better. So first one is we will have to prove for, so step 1. Step 1 is we need to prove P of 1 is true. We need to prove P of 1. What is P of 1? Let's try to find what is P of 1. So P of 1 is wherever n is there, put 1. So you'll get AI, P of 1 is colon, not equal to colon, AI plus BA power 1 equal to A power 1 into I plus 1 into A power 1 minus 1 B into A. And if you simplify this, this will become AI plus 1 into 1, A power 1 minus 1 is 0, so BA. So right side also this one, left side is also AI plus B whole power n. So both are equal. So when I put n is equal to 1 here, I am getting this. So when I put n is equal to 1 here, I am getting this, and both are matching. So therefore P of 1 is true. Therefore P of 1 is true because both are equal. Even I need not put 1 here. This is equal to this is always true. A plus BA equal to A plus BA. Therefore this statement is true when n is equal to 1. Right? This is P of n. Now that was step 1. Step 2 is, let's assume that P of k is true. So what is P of k? That is P of k statement is what? P of k is AI plus BA whole power k equal to A power k I plus k A power k minus 1 B A. So wherever n is there, you have to put k in this. Wherever n is there, you put k. k into k minus 1, you will get this statement. Now we have assumed that this is true. This we need not prove. We can assume that step 2 is true. That is the procedure for the PMI, principle of mathematical induction. Right? So I should be writing here. Before the step, we will say we will prove by principle of mathematical induction. In short, we call it as PMI. PMI means principle of mathematical induction. Okay. So we have step 2 where we will assume P of k is true. Now step 3 is we have to prove. Step 3 is we have to prove. We need to prove P of k plus 1 is true. You have to prove that P of k plus 1 is true. And what is P of k plus 1? P of k plus 1 statement is colon. That is wherever n is there, we have to put k plus 1. So it will become ai plus ba whole power k plus 1 equal to a power k plus 1 I plus k plus 1 a power k plus 1 minus 1. So wherever n is there, I am putting k plus 1. That is your P of k plus 1. So wherever if your P of n is this, so wherever n is there, I am putting k plus 1. Again here k plus 1 into k plus 1 minus 1. Then we have BA. B into A. So this is, we have to prove this. We have to prove this value equal to this. We have to prove that value of this is equal to this. So we'll start with this. We'll start with LHS of, what is LHS of P of k plus 1? Left hand side of k, this which is this. That is AI plus BA whole power k plus 1. That is equal to, now we have to show that this is equal to this. I can't write this equal to this here. I can't write this equal to here. I have to show that this is equal to this. I have to get this from this. So this is what this can be written as AI plus BA into AI plus BA power k. Where k plus 1 means I write the AI plus BA power 1 into this. So when you multiply these two, you will get AI plus BA whole power k plus 1. Now what is AI plus BA? So I will write here. Continuation I will write here. So that is equal to AI. I am writing this again. AI plus BA whole power 1 into AI plus BA power k. That is equal to. Now what is AI? Now let's multiply these two. Okay, before that let's apply. What is A power k? AI plus BA power k is, I can put this. So this will become AI plus BA into the value of AI plus BA power k. That is equal to this. We'll substitute this in the place of this. So this I am going to write it here. That is AK I plus k A power k minus 1 BA. So instead of AI plus BA whole power k, I am writing this because AI plus BA power k is equal to this. So I am writing this here. So that is equal to, now multiply. So this into this. Now A into AK is AK plus 1. Then I into I. I into I is I matrix. To multiply I matrix with I matrix, identity with identity will give you identity. Plus A into this. So that is K. Then A into A power K minus 1 is A power K. Then B. I am writing all the small letters. K, A, B, all are numbers. Then I into A. I matrix into A will give you A. When you multiply any matrix with I into A is always A, plus BA into this. So this into this. So B into it. So this will become A power K B. First I am writing the small numbers. Then the matrix A into I is A, plus again multiply B. This is K. A power K minus 1. B into B is B square. A into A, capital A is capital A square. capital A square. Now let's try to find what is it. See, A we know, A is this. Let's find what is the value of A square. Now let's find what is the value of A square. I'll do the A square here. Or we can even do here. That's okay, I'll do it here. What is A square? A square is A into A. A matrix into A matrix. So A matrix is 0, 1, 0, 0 into 0, 1, 0, 0. Now if you multiply this, what do you get? 0 into 0 is 0, plus 1 into 0 is 0. 0 into 1 is 0, 1 into 0 is 0. 0 into 0 is 0, plus 0 into 0, 0. So 0 into 1 is 0, plus 0 into 0 is 0, 0 plus 0 is 0. So you get 0, which is 0 matrix. You get a 0 matrix. So this whole value will become a 0 matrix. Because A square is 0, your A square is 0, which means this entire thing will become a 0 matrix. See, all these are matrices. This is a matrix, this is a matrix, because the moment you see 1 is a matrix, this is a number. So number into matrix also a matrix. So this will become A k plus 1I plus k A power k B A plus A power k B A plus this will become k A power k minus 1 B square into 0, because A square is 0. So which means this entire thing will become 0. So you get here, if you take A power k plus 1 into I, A power k plus 1 into I, plus here if you observe what is common between these two. Here I can take A power k B A as common, then I will get k plus 1. Plus this will become 0, because this is 0 into everything is 0. So you get A power k plus 1 I plus this, I can write my k plus 1 first. This I am writing first. Then A power k, I can write A power k as A power k plus 1 minus 1. I am just trying to get it in this form. This is what we have to prove. We have to prove this is equal to this. So we started with this, and we are doing all this to get this. And we got A power k plus 1 I, this one, plus k plus 1 A power k can be written as k plus 1 minus 1, so that it is in this form. Then B, this B, then A, this A. So we have proved this. So we started with this, and we have got this. We started with this and we got this. Here, these two are matching. So therefore, so in the left side what we have this A, B, A power k plus 1 here. That is equal to this. Therefore, P of k plus 1 is true. We have proved that P of k plus 1 is true. Therefore, by principle of mathematical induction, therefore by PMI means principle of mathematical induction, this one, right? By PMI, P of n colon, which is AI plus BA whole power n, this is true, equal to A power ni plus na power n minus 1 BA for every n belonging to n, Therefore, by PMI, this is true. This is equal to this. This is equal to this. That is true for this. Simple for this means for every n belonging to natural number n. For every n, this is true. Fine. So all of you can pause the video and take the notes and go to the next problem, which is the second one. I'm erasing all this. So given is A matrix. A is 1, 1, 1, 1, 1, 1, 1, 1, 1. And we have to prove that, to prove is A power n is equal to 3 power n minus 1, 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 3 power n minus 1 for every n belonging to n. We have to prove this. If A is this, we have to prove A power n is this. Now again, when we have to prove anything for every n belonging to n, we'll use the technique called principle of mathematical induction. Whenever you have to prove anything for n equal to n, for every n if you have to prove, or for any set of all positive integers if you want to prove this, then we will use the technique called principle of mathematical induction, which is same as how we did the previous problem. So solution or proof, whatever, right? TP means to prove. Okay, so solution is we write the statement P of n. What is P of n colon? That is this statement: a power n is equal to 3 power n minus 1, 3 power n minus 1, 3 power n minus 1, again 3 power n minus 1, 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 3 power n minus 1. So that is our P of n. Now we have to first step for PMI. So we'll say we will prove using principle of mathematical induction. Mathematical induction. We call it as PMI in bracket. Right? So for that, step 1. First step is we need to prove P of 1 is true. We have to prove that P of 1 is true. Now what is P of 1? So P of 1 is P of 1 statement is a power 1 equal to, I'll put 3 power 1 minus 1, 3 power 1 minus 1. So wherever n is there, I'm putting 1. 3 power 1 minus 1, 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 3 power 1 minus 1. Fine. So that is equal to, now 3 power 1 minus 1 is 3 power 0. 3 power 0 is 1. 3 power 0 is 1, 1, 1, 1, 1, 1, 1, 1. We get here 1 and a. Here a. But which is true because a is given as this. A is 1, 1, 1, that is given. A equal to this. So therefore P of 1 is true. So therefore P of 1 is true. Now second step is we need to assume P of k is true. That is our step 2. Step 2 is we need to assume. So step 2 is let's assume P of k is true. And what is P of k? P of k statement is P of k colon is a power k equal to 3 power k minus 1, 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 again 3 power k minus 1, 3 power k minus 1, 3 power k minus 1. So wherever n is there, you put k, you will get P of k. Now this is we are assuming, let's assume that this is true, which means wherever you see a power k, I can put this. So this we are assuming. Now what is our, now step 3 is we need to prove P of k plus 1 is true. We need to prove that P of k plus 1 is true. We need to prove this. We need to prove P of k plus 1 is true. That is we have to prove, that is, I'll put IE. IE means that is what is P of k plus 1 statement? That is a power k plus 1 equal to, we should show it as 3 power k plus 1 minus 1, 3 power k plus 1 minus 1, 3 power k plus 1 minus 1. So wherever n is there, you have to put k plus 1. To put P, so this is P of k plus 1 colon a power k plus 1, 3 power k plus 1 minus 1, 3 power k plus 1. Wherever n is there, we have to put k plus 1. That's what I'm doing here. 3 power k plus 1 minus 1, 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 3 power k plus 1 minus 1. And we should prove this. We should prove a power k plus 1 equal to this. This we have to prove. Right? So how do we prove? So we'll start with this. We'll start with a power k plus 1. We are starting with this, we have to get this. You can't write a power k plus 1 equal to this here. You have to prove that. Now a power k plus 1 can be written as a into a power k. And what is a? A is this one, 1, 1, 1, 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1. That is a. Into a power k. A power k is this one. 3 power. What is a power k? A power k is here. Value of a power k is this. We have assumed that this is true. So which means we can use this. Instead of a power k, I'll write this. So 3 power k minus 1. 3 power k minus 1. 3 power k minus 1. Into 3 power k minus 1. 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 Right? Now let's multiply. So 1 into 3 power k plus 1 is 3 power k plus 1. So 1 into this, so which is 3 power k plus 1, sorry, k minus 1, k minus 1, this k minus 1, k minus 1 plus 1 into 3 power k plus 1, 3 power k minus 1 plus 3 power k minus 1. So this into this plus this into this plus this into this. Usual matrix multiplication. Again now this into this. 3 power k minus 1 again plus 1 into this, that is 3 power k minus 1 plus 3 power k minus 1. Again this into this, which is 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. Fine. Now again this into this, that will become 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. Again 3 power k minus 1 plus 3 power k minus 1 minus 1 plus 3 power k minus 1. Again 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. Again 1 into this will give you 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. Again 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. To multiply this into this plus this into this plus this into this. Again this into this plus this into this plus this into this will give you this. Again last this into this is 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1. Right? So that is equal to what? Now 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1 means 3 times we are adding. So that will become 3 into 3 power k minus 1. Right? Again this will be 3 into 3 power k minus 1. This one. Again this will be 3 dot means into 3 power k minus 1. Again 3 into 3 power k minus 1. 3 into 3 power k minus 1. If you add 3 power k minus 1 plus 3 power k minus 1 plus 3 power k minus 1 will be 3 times 3 power k plus 1. Again 3 times 3 power k minus 1. Again this is 3 times 3 power k minus 1. 3 times 3 power k minus 1. 3 times 3 power k minus 1. Sorry, I'm writing too small. Sorry. That is equal to, now 3 into 3 power k minus 1 is 3 power k. This will become 3 power k. This will become 3 power k. 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 So what is that? That is equal to this. Because value of this is what? 3 power k plus 1 minus 1 means 3 power k. Right? Which this can be written like this. Right? So we have got this. So a power k plus 1 is what? This. But this is same as this, because 3 power k plus 1 minus 1 is 3 power k. 3 power k, 3 power k, 3 power k, k, because plus and minus 1 will cancel. You get only 3 power k. All are 3 power k like this. So we have proved p of k plus 1 is true. So I'll write the conclusion here. So therefore p of k plus 1 is true. Therefore by PMI, p of n colon, that is a power n equal to this one, 3 power n minus 1, 3 power n minus 1, 3 power n minus 1. Similarly, 3 power n minus 1, 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 3 power n minus 1. For every n, I will say for every n belonging to n. Right? So after this, the conclusion is therefore P of k plus 1 is true. K plus 1. Sorry, my handwriting is not, I mean, it's very bad. I'm sorry. I'm trying to write as best as possible. I'm sorry. In case if you are not able to understand, sorry. So P of k plus 1 is true. Therefore, by PMI, P of n is this. For every n belonging to n. So we have proved this. A power n equal to this. For every n belonging to n. N means set of all natural numbers. Fine. So all of you can pause the video and take the notes. And I will stop the video here. You all can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.